Okay, so I've been looking at your work, and for the most part, it's very good. Again, I'm just seeing a lot of the answers only, but as long as you're using the right formulas and you're using your calculator, answering it, keeping it in pi form preferred, two decimal places otherwise, it's going pretty well. Just want to show you a couple things, and I know you might not see this on your quiz that's due Monday, your take-home assessment. But I like these questions, like page 640, number 20. Um, they want to find the volume of the composite solid. It's a cube, okay, and each a cube of all sides are equal, of course. So the volume is 12 cubed, which again my calculator will tell me is 1,728. And then they have a square pyramid kind of inside. It might be rectangular here, so the key is that the pyramid's inside. If you can visualize, the pyramid is inside the cube and you're taking the pyramid out. So I know the height of the pyramid is 12, and then the area of the base, I know that all the sides are equal. So in other words, all of these are of length 6, which would imply that each side here is 6 radical 2. So the area of the base is 6 radical 2 squared. So the volume of the pyramid is 1/3 the area of the base times the height. So if you type that in your calculator, 6 radical 2 squared is 72. 72 times 12 and take 1/3 of it. That's where you're going to get the answer, and then I would just subtract that. So the volume is 1728 minus 288, which is 1440. 1,440, and it looks like it's in inches, so it's cubic inches. Composite solids we would have spent more time on uh, if we had a regular class, if you will. Uh, the formulas for cones are pretty straightforward. The surface area, I want to make a point, it's the area of the circle plus pi r L. And again, that L stands for what is called the slant height. So that's the difference. Remember, if I have a cone here and I'm drawing to its perpendicular to the base, that's going to be the height, okay? The slant height is essentially the hypotenuse, if you will, from the radius and the height of the cone. So you can visualize let me just get you to see that a little bit clearer. You can visualize a right triangle inside of the cone where the radius is the bottom, if you will. The height is straight down, okay, from the point, from the vertex, and then the slant height, of course, is the hypotenuse. So, that might be of interest when you're doing surface area. And again, you don't have to memorize these formulas. The volume of a cone is 1/3 pi r squared h. This time the height is from the vertex perpendicular to the base, okay? It's the same formula essentially as a cylinder, except it's 1/3. Okay, that's not a big deal, and most of you went through that pretty well. Again, looking at number 16 on page 645, this is the kind of stuff I would have spent more time on if we were in school. But you have a cube, if you will, okay, where each side is 5.1 meters. So you know the volume is 5.1 cubed, okay? And then you have the cone inside. Now, the radius of the cone, see, what is the radius of that cone? You visualize the circle. You probably say the radius is going to be half of 5.1, and the height is 5.1. So the volume of the cone is 1/3 pi r squared h. And that's that I would expect. And this is a calculator, question, if you will. I mean, you just big type out, and you get about 22.11 pi. So it's a weird answer, but 5.1 cubed minus 22.11 pi, they have an answer of about 63 point whatever. Now, the answer in the book is a little bit different because they have the circle as kind of tilted in there, if you notice, and that's what makes this a little bit harder to do. But if the circle is kind of this way, now you have to visualize, maybe a right triangle Pythagorean's theorem to figure that out. I think that that's not the best way to do it. So your answers might have a little latitude than what you might have done. The last section, again, surface area and volume of spheres is very straightforward. If you just use your formula, you should be okay. The word hemisphere is used because it's half of a sphere, and I would just use the formulas to figure that out. Again, finding volume of a composite solid, like if you look, it's 26. It's almost like a tube. You have a cylinder. This is 26 on page 653. So you have the cylinder, so the volume is pi r squared h, and then you have two hemispheres, if you will. So each hemisphere, the volume of a sphere is 4/3 pi r cubed, but you're taking half of it. So whether you do it this way, or since it's half here and half here, it would just be 1. So that's your choice. But they tell you that the radius is 10 and this length is 18. So you can just fill in the blanks here. Each hemisphere is 1/2 of 4/3 pi r cubed. So if you times that by the two hemispheres, it's going to be whatever that answer is, plus pi r squared h. And that's the answer you're really looking for. And again, you'd have to type that all out. 10 cubed is, of course, 1,000 times 4/3. You're going to get a fraction. See, I like pi form here, but 1,333.33 pi plus 1,800 pi. And then again, since you're adding two pi's together, it's pi in the answer, certainly not pi squared. I hope you know that. But if you add them up, you get 3133.33 pi, and it's volume, and the units are meters, so it'd be square meters. Okay? And your textbook has an answer that's I'm looking at number 26. You get an answer that's there. Oh, I'm sorry, I did 25. I mixed up the numbers. This would be the answer if it was given. I just did the wrong problem. 26, the information is that the radius is 6 and the length, the height of the cylinder is 14. So use those numbers, you'll get a different answer. And then 25, I just looked at the wrong problem. I'm sorry. So 25, you have a cylinder whose radius is 10 and the height is 18. So the volume is pi r squared h. And then there's only like one hemisphere here. There's nothing on the other side. So here it would be 1/2 4/3 pi r cubed. Type that in, and add it together. Okay? So just finish this homework, and then you have the take-home assessment due Monday, June 8th. And if you have any questions, chat with me tomorrow or Monday. Okay? Have a good day.